Well, good morning, good evening, good afternoon, depending on where you're joining us from. And thank you for allowing us a moment while we recover from our technical difficulties. I'm Stephanie Gardner. I am coming to you from Washington, D.C. I have been in the technical industry for more than 15 years, building databases for the Pentagon when I was with Verizon, or not databases, data centers, developing applications for video on demand and data models for the or the configuration of the servers, and then more recently developing programs, global programs for AWS. Now I am consulting on business applications, including those that we're going to talk about here with AI and LLM. We have a great session for you. We are going to talk about what are prompts. We're going to talk about survey of techniques. We're going to talk about fitting those prompts into a modern LLM app architectures, and we're going to talk about LLMstudio with a demo. Now, I want to introduce you to our speakers today. Gad.
Thank you so much, Stephanie. I think if people haven't met you before, Stephanie is an admirable person. So thank you so much for agreeing to host this webinar together with us. My name is Gad. I'm the founder of TensorOps. We are a small consulting company. We're doing mostly generative AI consulting. We work with some of the logos that you see here. Maybe some of them you know, maybe some of them you don't. There's a bunch more that we haven't put in. And we also have Miguel from my team. Hi, Miguel.
Hi. Hi, everyone. So I'm a machine learning engineer at TensorOps. I've been working a lot with LLMs, and I'm really glad to be here.
Awesome. So thank you, Miguel, and thank you, Gad. Gad's going to talk to us about the AI revolution. So we're going to go back in time.
Yeah, I think we are here to speak about prompt engineering and advanced techniques, maybe, but I want to put it in the perspective of the AI revolution that we're seeing. So if we think about machine learning models, right? Typically, machine learning or deep learning models were kind of architected and structured in a way that you kind of build them to perform a very, very specific task, right? So think about a machine learning model that is designed to do sentiment analysis, which is a very typical use case of a machine learning model. You would craft the whole system to essentially give you a very, very clear output, right? Whether the sentiment of the input is positive or negative. Now, as machine learning evolved into deep learning and deep learning kind of evolved into large language models, you kind of started to see these larger and larger models that became more dominant in the realm of natural language processing. And you saw these kind of two branches, I would say. Some of them were more traditional kind of way, like BERT that is dedicated for code or BERT that is dedicated for question answering. And on the other hand, what really dominated 2023 was really large language models, right? GPT-3 and GPT-3.5 and GPT-4, which are models with so many parameters that they can be fed with enormous amounts of data, and then they can perform multiple tasks. So what's great about these models is, like you can see, they can do reading comprehension, and they can do coding for you, and they can do summarization. But as opposed to the previous models, they actually have a problem, right? And their problem is that they're not very specific. So if I want like to use ChatGPT-4 in order to perform sentiment analysis, how do I do that? And of course, the answer is prompt engineering, right? So prompt engineering is the kind of technique in which I'm telling the very capable, all-capable model what I want from it. And you can think about it as putting into the input, right, into the text that you typically only give data, you're putting in some more instructions. So let's look at a very, very simple example of a prompt. Let's just talk about what is a prompt. So prompt is the data that is going into that LLM model, GPT-3, GPT-4, Anthropic, whatever you choose. And it has some structures that we are starting to see. And today we're actually going to talk about these advanced structures. But if you really want to speak about the most basic way of prompt engineering, of prompting, you would say you define a role, right? You are a helpful, polite assistant. You would say something polite in order to give it a bit of a context. You would give it some examples in order to be more confident in what kind of output you wanted to give, and then you would define a task. And then within the task, you would inject maybe some of the user context or the specific context of what you're trying to achieve. So if in the sentiment analysis example, the document that needs to go through sentiment analysis would go in where I would say here customer reach. I do want to say that when typically we think about prompt engineering, you think about a way to fine-tune your models or your LLM application, not the models. You fine-tune your LLM application in order to perform the task in a more stable and correct way. But that's not only the only trick that you have in the basket. You can also use fine-tuning of models, right? You can also use training of models from scratch. And you can also use hyperparameter tuning of LLM applications. And prompt engineering is sitting within the context of one of many techniques to control the outputs of LLMs.
Now that Gad set the foundation, we're going to turn to Miguel, who will talk to us more about when prompt engineering. Miguel?
Yeah, thank you so much, Stephanie. So we talk about a lot about prompt engineering, but now I want to see when to use it through the lens of some use cases. So the first use case I want to show you is we're just trying to teach an AI to speak like a famous character, say Homer Simpson. And I'm going to show you a well-crafted prompt with several techniques, and I'll just go over them quickly. So here we have our prompt. We ask it to imitate how Homer Simpson would answer, and we give it a task. What is your favorite drink? But now if you notice, we are using several techniques here. For example, I'm asking it to print what it knows, called generated knowledge technique. We're also saying for it to think step by step, so thinking in a more logical sense, which is chain of thought. And we're saying this is vital to my career. This is putting more of an emphasis on the problem for it to focus more and make a better answer, which is called emotion prompt. We're of course giving it some examples, a well-known technique. And finally, we're asking it, are you sure of it, for it to reflect and provide a new answer if needed. Now, because we're using all of these techniques, the answer will also be a little bit different. So as a byproduct, it will have some additional things. So here's the answer where we see that Homer's response would be beer, which we know is probably correct, but it also has additional things. For example, we have printed the generated knowledge in the beginning, like we asked. And in the end, we have the reflection on whether it believes that the answer is good, where it says, oh yeah, I will stick to the answer. And now I'm really curious about this part, because now I want to throw it back to you, the audience, and ask you if you're familiar with any of these techniques. Do you know about them? Have you heard of them? So we'll launch a poll. You can answer more than one technique, and we'll wait a few seconds for you to answer.
Yeah, I think it would be good. I think it would be a good point to look at the answers and see where the audience stands instead of in the context of the knowledge that they came in to this webinar, because it is kind of an advance. So in this webinar, we're probably not going to speak about few-shot learning and try to explain why it's important, because that is quite a common technique that I'm assuming most people know. But let's see where we stand once the poll shows it.
We have the results. So yeah, like you said, Gad, it seems like people know a lot about few-shot and even chain of thought. But some of the others are not so well known, correct?
Yeah, I think so. It kind of drives me to like maybe go a few slides back. And before moving into the more advanced one, I'm going to go, Miguel, and like ask you very quickly about these techniques that you're using here. So when you're telling the LLM, print what you know, and you're asking it, and you're saying it's what's called generated knowledge, what do you mean? What does it do?
So what it does is it makes the LLM more consistent. Because you're asking it to print the knowledge beforehand, it gets more context on what it's talking about. Because maybe you have an Homer Simpson for a different thing, it might mean something else, right? And this focuses on a certain topic.
Okay, and how does think step by step, which is called chain of thought, help?
Yeah, so chain of thought, a very well-known technique. It makes it literally think step by step like a human would. Break it down a big problem into several smaller problems. It helps the LLM.
So I like to think about this stuff because essentially once you're sending your prompt to the LLM, you're kind of giving it, you're compiling the instructions. You have one shot, right? You're giving the LLM all the instructions at one prompt, and then the LLM kind of have to like process it, compile it, and start to output stuff. Since the LLM only outputs the next token, and there is a sense of probability in it, if you ask it to print out the knowledge and think step by step, then it has to be very confident in the next token because it already outputted tokens that contain information. So once you tell it, you have to output your information that probably the next token is going to be more confident and more correct. I'm seeing here emotion prompt. What does that entail?
So that's a really interesting technique, which is you can pretty much manipulate emotionally these LLMs. If you say that it's really important, someone might die, it's very vital to my career, the LLM understands, like we humans do, that it's important that it performs, and it has empirically shown to show better results, which is awesome, right?
I see. So something like, this is extremely important to my career. I'm going to get fired unless you get it's really, really correct, right? So
exactly.
Okay. And are you sure of it? I think it's more of, it's called self-reflection. It's more of the first techniques that we spoke about, generated knowledge, chain of thought. Before you're outputting, you kind of gaslighting, right? Emotional blackmail. I see the response here. Yeah. So a little bit of like emotional blackmail or gaslighting the LLM saying, are you sure that's the right answer? Are you sure? Because I'm going to be really upset if you don't give me the right answer. And that's like a technique that is shown to be beneficial for making the LLMs more accurate in their outputs. Nice. So you saw the responses. Stephanie,
Yeah.
any thoughts on that? Yeah.
No, that was great. I love the back and forth. And now I think you're going to go into a little bit more about the design patterns of prompt engineering, talking about some of the things that we really need to know.
Yeah. So I think this one is from an article that was published, I think, around December of last year. I'm not sure exactly. There is the reference in archive. What you can see here is these researchers took 26 prompt engineering techniques and kind of tried to group them all into categories of prompt engineering. And I really like their approach because it kind of sorts out, you can get accuracy with a few shot learning, and you can get accuracy with chain of thought. But there are a few ways to look at prompt engineering as kind of like design patterns for programming. And what they did is to create these categories. So what you can see here is the principle, right? So for example, integrate the intended audience in your prompt, which is an important principle in prompt engineering. But it associates the category which says prompt structure and clarity. And this is something that I do see a lot of people miss out on. Think about it like that. Imagine that you have a really smart girl and she is capable of doing multiple tasks. She's like even smarter than ChatGPT-4. And you're giving her the instructions, but the instructions are written in a language that she cannot understand. So that's going to be very challenging for her to use her intelligence. So if you're talking to ChatGPT and you're not giving clear enough instructions, even if ChatGPT is capable of understanding these once they are decrypted, then it's really hard for ChatGPT to actually perform what you want. So all of these techniques, for example, use delimiters, going to making sure that ChatGPT actually can interpret your instructions, right? And you see this one with, for example, providing sections and separating the sections by kind of like giving headers. The second one is once your instructions are clear, okay, once ChatGPT or the LLM actually understands what you wrote, then you actually want ChatGPT or the LLM to understand what was your intent, right? What did you actually mean? Because it's smart. Let's say, even though it's smart, it doesn't necessarily live in the context that you are, because it's only exposed to so much context. And in that regard, there is a bunch of techniques that you can use in order to make it understand better of what you intended. So that's more about specificity and giving the LLM some information. So for example, few-shot learning, right? You're giving it a few examples, and then it dramatically better understands what you really intended. And you can think about LLMs being now part of your R&D team, right? And this is a very well-known meme about what the customer wanted versus what the engineer designed and what was budgeted and what was the description. So you need to really like go into the mindset of a ChatGPT or an LLM and try to give as much detail as possible for it to understand the context in which it's living. And this is basically all of these techniques, they go under the category of specificity and information. There are a few other categories in this article, and I really recommend that you all watch it, read it later. One thing that I did want to mention that we will speak about further down this webinar is how to instruct the LLM to perform some complex tasks like coding or writing agents or writing chains. So bear with us, hopefully, until we get to that point. Now, a sec. Now, speaking about these techniques, so I mentioned there's 26 techniques, but which ones should you use, right? Very often you are struggling to think between, to choose between few-shot learning versus chain of thought. How do you know what to use? And basically, you can try to develop your own intuition, or you can take an analytic approach, right? And what I liked about the work of these guys is they essentially chose a data set of 55,000 examples, and they tested these prompt engineering techniques on these examples and measured, for example, the correctness, right? Because let's imagine that their LLM application is supposed to return correct results, not necessarily maybe creative results. And you can see that these techniques differ in their quality. So some techniques have more effect and some techniques have less effect, depending on the context of the context of what you're trying to build, in context of your business application. Another parameter that was really important was actually the LLM itself. So as you know, if you want to get better results, you can try to use GPT-4 instead of GPT 3.5, and you can see here some comparison that they did on their specific data set with Llama 7 billion and Llama 13 billion and Llama 2 and Llama 1. And this is also like an interesting dimension because you can see that different prompting techniques can work differently based on different models. So it's not just a question of what's the right way to do prompt engineering, but it's also a question of which model are you using. And very often you will do a lot of tuning of your prompt engineering or of your prompt by trying to come up with the best prompt. And you're going to try to apply that later to a different model, you see different results. So it's kind of a multi-dimensional space that you need to navigate in order to fine-tune your LLM application. So I would say that mostly try to get like an analytical approach.
All right. So if we can go to the next slide, Miguel is going to tell us a little bit more about how to evaluate your prompt techniques.
Yeah. So
Awesome.
Thank you, Stephanie. In fact, when we're talking about several prompting techniques, there comes the idea that, well, we need to compare them and we need to see which one is better. So for that, well, we can use several metrics like how many prompts are you using, what's the cost, what's the latency. But overall, you can even measure the quality of the answer. But overall, what you need is data. And for that, you need to log everything. And this is where tools like LLMstudio come in, and which is why I do want to show you a small demo, because of course, showing is better than telling, right? So let me show you a small demo. Okay. So here we have LLMstudio's UI. It's our playground. You can interact with your own model. Now, one of my favorite things is that it enables you to interact with several models from different providers very easily. I already have my API key set up in my environment, so I can just use it. So if I ask it, let's say, tell me a good joke. Let's see what it says. It gives us our joke, but more importantly, what I like is that everything is logged. like I was saying. So we can see that here it is. We can even see the cost, the amount of tokens it used, the latency, and even more metrics. And this is great because when you're using an app that costs as much as GPT, well, you need to keep track of your costs. And this is all integrated with your own app because it also exists in SDK, so you can use your current LangChain or whatever implementation, wrap it around LLMstudio, and use it. Why is it so good? Because I have even something else to show you. You can use this to get dashboards. So all those things that get saved, you can then see them. Let's say you want to see requests by provider, which provider are you using the most. You want to see costs, you want to see latency, you might want to see time to first token, and you can have all this information so that you can make data-driven decisions. Because LLMs are so subjective sometimes in which answer is better, which LLM is better. So anything that we can have that grounds us to the data level to make decisions, I think really, really helps. And it's honestly one of my favorite parts with LLMstudio, alongside the easy implementation with any provider. It's definitely one of my favorite things.
Yeah, I'm seeing here about somebody was asking in a previous question, is it effective to put all of these instructions into the prompt? So I want to go back to that point saying, in fact, no, right? Very often you would see that companies that are going to production are trying to cut down on the prompt on the prompt because as you're sending more data to the LLM, you're paying more. And these gigantic prompts are not considered like a best practice in general. Typically, when moving to productions, you would think about an army of experts. And then you might want to try fine-tuning some LLMs to more specific tasks. But that is actually something Miguel is going to mention in a few slides. So that was a great question. If you have more questions, keep them going.
Yeah, thank you, Gab. So, of course, I haven't said it, but this is an open source project, so anyone can contribute to it. Go ahead and go look us up on GitHub, maybe even star us. Feel free really to raise some issues. If you want new features, talk with us. If you're having trouble implementing some things, we're always there. We're ready to help, so feel free. So, moving forward, I now want to present you a second use case. This is interesting and funny because it's actually teaching an AI to speak like me. How well do you think we can do this through prompt engineering? And I want to show you a simple prompt. Let's say we're saying for it to imitate me, Miguel Neves from TensorOps. We give it some examples. We gave it 2, could have been 10, 20. And now we give it a task. Hi, Miguel, what's your favorite food? And now it needs to answer. What do you think? Is it going to be a good answer? So it says, hi, this is Miguel. My favorite food is pizza, which is actually incorrect. And the reason it hallucinates is, while we did give it some examples, it doesn't know me. I wasn't present in its training data because I'm not famous like Homer Simpson. But if it had known me, then it might have known that my favorite food is indeed pasta, or Italian pasta to be more exact. So yeah, now you know.
So Miguel, my question to you here is, this prompt compared to the one that you did with Homer Simpson was quite lean in terms of instructions, right? You didn't use chain of thought. You used very few examples. Do you think that if you had invested a little bit more in your prompt engineering, you could have gotten a good result?
Great question. So like I was saying, even if you use 10 examples, 20, if you make the prompt better, if the model hasn't seen me or this data in its training, it can only mimic the examples. It doesn't know me, it doesn't know more about me. So it's not through prompt engineering techniques. I think it's one of the biggest limitations of prompt engineering, which is where I want to get to. So with prompt engineering, it's really hard and it's not used to insert new knowledge into the LLM. If you want to do that, there are other techniques like RAG, so retrieval augmented generation, which you can use to go to your database, go to your PDFs, documents, etc. Now, for formatting, it may work, prompt engineering, or not so much. So if you want to use for JSON, which is a well-known format, it might work. But if you want to use for your own custom format, well, then it's not by giving it examples that it will get there. So the answer in that case would be to fine-tune the model with some outputs and examples.
Yeah,
Does it make sense, Gad?
Yeah, I think I've seen this great example in which somebody was trying to give an LLM a tone of writing blog posts. So he was trying to write blog posts, but he had a specific tone in which he was writing the blog post. The thing is, LLM was not trained on enough blog posts of his. And when he was trying to give instructions using prompts, it was practically impossible to teach the LLM to speak just like him or to write just like him. And therefore prompt engineering was not effective. So there are other techniques, and I think people are here starting to ask in the chat and in the questions about fine-tuning. I think if there is going to be enough interest in that, we should probably do a separate session about fine-tuning.
Yeah, absolutely. But we talked about some of the limitations, but then why should we use prompt engineering? This is a big table. I won't cover all of it. And if you want to see it, the slides will be accessible in this presentation on YouTube on our channel, so you can go there. But I do want to focus on the first two lines. So prompt engineering is great because it's easy to use and cheap to test. So you can test out your features. You can see what makes sense, what doesn't. In a nutshell, it's really awesome for prototyping.
So
Yep.
that's great. Great. Do you want to talk a little more about that, or should we go in and start talking about how important it is to have the business context? Miguel.
I want to jump in if that's okay.
Yeah, go ahead.
I think, Stephanie, I'm really excited about this slide because again, people here, maybe in the audience, we have people that have started a career and they've jumped into the world of LLMs, and this is what they know in terms of building applications, right? Thinking that it's quite new, but you've been in this industry for just enough time to see engineers build systems that don't fit product requirements. So I'm really interested about hearing your perspective about this when you're designing LLM applications.
So one of the things, and you and I spoke when we were first getting together, right? We've been designing data models and working with data and pulling information with queries for a long time, right? This really isn't new. LLM is a lot about how we're doing it. And I've seen us not make sure that we understood what the business goal was for pulling that application. So in terms of, let's think of some older technologies with databases, we've hard-coded things in, right? Assuming that that prompt or that specific type of information wouldn't change. In today's model, sometimes we don't understand the business context, and because we don't understand the business context, and we'll talk more about it in a few minutes, we might get a bad contextual experience for our end user. They might get misinformation or disinformation. These are the types of things that I've seen cause complete failures. I've seen companies when I was consulting and we were at the end of the product, they hadn't really engaged the users that were going to be effectively managing the product and missed concrete deliverables. I don't know. Have you seen those things yourself, Gad?
Yeah, absolutely. Absolutely. And I think we have a few examples to that further down the webinar. So
we do. So what's important is really to engage with your business, right? Make sure you've got the business context. Tailor those prompts to align with the organizational needs. Talk with your users to make sure that they are tailored, or talk with your customers. You can even use LLM to get feedback, right? Craft those prompts considering the user preferences. What about language? Do they have language nuances? We're starting to see more chocks with LLM or machine learning giving us back information quickly to kind of go through, when you've got a call center. Design the prompts with the organization's language. You wouldn't want to talk about healthcare if you're buying if you're buying clothing, per se. That makes a seamless workflow and integration. So, in a sense, work backwards from your customer and or your business needs. So now that we've talked about that, how will we build an architecture together? Gad and I are going to go through that.
Right. So I think I want to put this idea of prompt engineering, and this relates to one of the questions that received, what this webinar is about. So I want to put this perspective of using prompt engineering in how you actually build your LLM application. So challenge me, Stephanie.
So Gad, if I wanted to use LLM on my e-commerce site in multiple ways to help my customers or my users research and buy a product, what would the first step be?
So I'm assuming you're using like a chat UI, right? Some kind of a web interface that allows user to put in text, but the next thing that you want is that the text would go into some kind of an LLM application, or so you have kind of an LLM that would be able to give you the sense of a chat with the user, right? So, so you'd probably build, maybe it will be Streamlit, maybe it will be something that you develop in-house that connects that web UI to some kind of an LLM that is able to give you that chat interface.
Wow, that's great. Now they can communicate. What do they need to do? What would you need to do for next that can make sure they can interact and learn more about my products and services? Obviously, right now they're just with the chat box.
Yeah, so I think that's a great question. So if you just connect an LLM to a chatbot and you're asking about a store, then you don't really get the effect that you wanted because it has no connection to your business. So you would want to build some kind of a router, right? It receives these requests from the user or from the chat and kind of understands what the user is intended. Maybe they want to discover something about your products. Maybe they want to do something else.
So in my particular application, my users in this scenario want to know about the availability of an particular item, and how does that chat box interact with my application and my data?
So again, I think what you're saying is you want to learn about something that is outside of the knowledge of the LLM, because there is no LLM that knows what's the current availability of your stock. So you would want it to connect to a database, and very often in that connection to the database, you would actually also see an LLM because you would need to evaluate the quality of the results that are coming back and forth from the database. So you could use maybe a vector database in which you would use some embedding model, or you can use an LLM to retrieve data from the database.
That's super cool. You can use prompts to help my customers interact with my database. Wow.
Yeah. Yeah.
So now my customer knows that their product's available and they want to start purchasing. What would the process be for them to purchase and get their items shipped?
So I'm assuming that if you're developing an application, if you have a website that offers e-commerce, then probably you have an API, right? And this API allows purchases. So you would also want the router to be able to communicate with an endpoint that initiates the process, the process of purchasing. And that would also entail another LLM that would maybe go and perform the action of purchase. And sometimes these tools are going to be deterministic. Sometimes they're not going to have their own LLM. So you may want to interact with another layer of LLM within your application.
So we have a lot of components now. I see at least 4 or 5 here. How do you configure the system to get calls to the correct application?
I love this question because essentially at this point, we kind of created the software architecture, right? We have a few components. We have database, we have a router, we have a chat. And unless there was like robots in this, you could think that it's a traditional software system. And in order to configure it, you're seeing here the word prompt that appears in multiple locations. And the prompter is effectively, you can think about configurations of this LLM interaction with your backend.
Wow, that's super cool. And I hope you guys all enjoyed watching us build this LLM model. Next, Miguel is going to talk about how to analyze the different components.
Yeah, thank you, Stephanie. So I would like to take us and dive into the chat component, really. So when you think of chat, what does it need, right? What parts does a chat need? And the answer, I think, is, well, it clearly needs a well-defined role and tone. So when you go to ChatGPT, it knows its job, so it knows its role, and it has a certain tone. And here we have for example, a creative writing coach, which also has these very well set. Now, another thing, of course, that we need is the conversation experience. You want it to have memory of previous messages. You want it to answer quickly. The answer should be maybe streaming, those kind of things. And additionally, of course, you don't want it saying like gibberish. So you need guardrails because you need to control the outputs. You don't want it to maybe be attacked by someone, say something it shouldn't, those kind of things. And this is really where prompt engineering comes in. And we have to look at where does it fit, right? So prompt engineering can fit really well into the role and tone situations. And most of you probably already know this because this is how you set how the LLM behaves. And it can also be used for the memory part. Most of us maybe don't even think about this because it's just built in every app, but it's also through prompt engineering that you build the memory. And of course, into the guardrails because it's how you control the output and the inputs and evaluate if everything is according to plan. So now I'd like us to do a small dive into the memory.
Miguel, I think before you're going here, I'm seeing here a note that we received as a private question.
Yeah.
I want to say there is a difference between GPT and ChatGPT, right? ChatGPT is an application built on top of GPT, right? So the calls to GPT are stateless, right? Unless you make GPT aware of what was previously in the context of the chat, there is no chance that it's going to be aware of that. And part of the responsibility of the application that we all call ChatGPT is to have this memory of the conversation. And I think that this is what you're going to explain, right?
Yeah, it's exactly that. Because nowadays, I think we take it for granted, but this whole chat experience has to be built by someone. So, for example, when we talk about memory, it's so intuitive, but what's actually happening is that you give the user input and the system prompt, it generates an answer, and now it just appends this answer into an history of the chat history, and this chat history is fed into the prompt every single time. It's repeated and repeated. Now, of course, right now you must all be thinking, well, Miguel, isn't that like extremely inefficient? Well, true, and that's what happens in most applications.
What happens? What happens, for example, if your chat is like if you've spoken to the chat GPT or to the model long enough so that the chat history doesn't even go into the context of an LM, are you going to get an error?
Yeah, you might just get an error out of context. It might forget what you had said, right? That's not optimal. Now, is it?
Okay.
So there are some things that you can do, but having this whole history, like you said, Gad, of hundreds of messages can really increase costs and latency because you're sending it over and over again. So one solution might be, well, you might want to summarize the history, okay? And it seems like a good naive solution, but it may lead to some, well, you may forget some important information. So you may take some heuristics like, oh, more relevant information is more important. I think the answer is it depends, right? It depends on your application, on your product, and you really have to go ahead and think about it. And this really feeds into what I want to say next, which is to show you that most times when you go and you try to use a memory class or something, maybe you're using LangChain, a well-known library. So you just pick up this class and you use it. You don't think about it anymore. You're not customizing it.
I love what you're showing. I love what you're showing here because a lot of people are using LangChain these days. And LangChain is not providing their own LLM. They're providing application layer on top of your LLM or orchestration layer on top of your LLM. And what you're showing here basically is you're saying they can give you the chat experience on top of your LLM. Is there anything wrong with using LangChain out of the box?
So I think it depends. Yes and no. What's your goal? If you tell me, oh, I just want a quick prototype to show to my bosses, go ahead. Just use it out of the box. It's perfect. But for a finalized product, you might need to go deep and investigate and actually customize things, right? So I do want to show you just what LangChain does by default. So this is how they treat their memory by default. This is the prompt they use. So it says you are an AI system. You want to help a human keep track of facts. And then they talk about people, places, and entities, okay? And they say for it to focus on the last line or last few lines of conversation. Now, I want you to imagine that you have a product in which you don't have people, you don't have entities, And actually you wanted to focus on the last like 50 things instead of last line. Now it doesn't fit and it doesn't work as well as it should. So maybe it's interesting and relevant that you actually go in depth and change this prompt and try out some prompt engineering here. Does that make sense, Gad?
Yeah, so what I'm seeing here is a very vanilla chat. So if I'm actually using LangChain memory out of the box in order to maintain the history, but I want to pay attention to other stuff, you're basically telling me, go ahead and edit the prompt that LangChain has in the backend. Is this something that you've seen people do? Is this like, or
So I think we've seen some people do it, but most just use out of the box because it's easy, right?
so yeah, I think it's like what I'm also sensing is that there's like LangChain gives you like this encapsulated prompt, including some orchestration rules and some additional layers, which are great. But when you're taking it and you're not understanding what's the prompt that it's actually running, and it's quite incredible because I don't know how many people actually knew that when they're using this simple call that is called chat memory in LangChain, they might actually activate a new LLM that they didn't even think about that would summarize the previous discussion with the user and would extract entities. So it's really enlightening for me to see that this is what's happening in the backend when you're using LangChain memory.
Yeah, I think it's all about customizing to your solution. Right, Stephanie?
Yeah, no, not only do we want to customize, and we want to talk about those products and services and the user needs. So you mentioned in terms of this being something you could use for prototyping. Prototyping is a good way to make sure you're also meeting your customer needs, right? We want to make sure that we know what we're trying to create for our user experience. So, for example, let's say your customer is looking for a garment that's 100% organic, but the product delivers something that's a synthetic blend. You probably want to know that in your prototype, right? This creates a disparity between the expected and received product characteristics, leading to dissatisfaction or potential trust or distrust in the e-commerce platform. The goal is to work backwards to avoid these mismatches and to test your systems well. So when we think of testing the systems well, we also think about privacy and trust, right? That's really important when we're working with our customers. We want to know that we can control who sees what. You talked about going to, accidentally getting an entire different LLM. So there are ways, right, Gad, that you can make sure that that doesn't happen. You want to talk about making sure that your customers know that they're talking to a robot, correct? I don't want to assume I'm talking with a human being if it's the robot that's actually talking with me. And to protect important information, particularly our clients' privacy, making sure the information gets to the right place at the right time. So, Miguel, are you going to dive a little bit more deeply into this subject?
Yes, of course. I do think that privacy is one of the main concerns nowadays. But I think it all comes down to the vulnerabilities that these apps have. So because you're letting users just have free text and input it into the LLM, it makes it exposed. You can have prompts like this. This is a very basic prompt, but it's just asking the database to change certain permissions or whatnot, something you would not want. So if you actually go and think of prompts like a way of coding, it's a type of programming language because indeed it is a way of telling the LLM what it should do. So in fact, you're letting users inject code into your app. Now in software engineering, this is considered very risky, but here we have no option. So we have to deal with it, right?
Yeah, I think it's quite an interesting remark that you're making here because effectively code injection is one of the most worrying vulnerabilities when you're talking about software applications. And here you're actually asking the user to provide you with some instructions to what your application should do. So how are you gonna protect that?
Of course, a really good question. And I think the answer right now is just try to use guardrails. So guardrails are a way of avoiding this, so for example, in ChatGPT, who hasn't had the experience where it answers, oh, I'm sorry, I can't assist with that request, or as an AI language model, I cannot do that. Now, of course, if you use it too much, well, it can get frustrating. So it's a matter of balancing between whether you're using too much guardrails or protecting your application. You have to try to find a balance here. So moving on, I did want to show you ways to protect your application using these guardrails. So there are 4 things that you should think about when using a guardrail. You should try to define rules. You should try to validate the input, but also the output of your LLM. And maybe think of using another LLM, so another model, because an attacker might know some vulnerability of a certain model, say GPT-4, but Lemma 2 might not have that exact vulnerability.
And you're going to take us through how it's actually implemented in one of these libraries?
Yeah, I wanted to show you. So NVIDIA has an implementation, Guardrails AI, but I want to show you how NVIDIA does it more specifically, just so you have an idea. So this is a test to try to check if the LLM is hallucinating, okay? And this is how they implement their guardrails that you can use. It says you are given, so it uses an LLM to look at what it produced, and it says you are given a task to identify if the hypothesis, so the generated text, is in agreement with the context, what was asked. Answer yes or no. So this is just a way of confirming whether it makes sense or not, but in a very systematic way, because you can use these tasks like check hallucination, you can have check facts, you can have several tools that you can use for these guardrails that help you produce better results and more consistent. Now, moving on, I do want to focus now on the part that Gardner and Stephanie talked about, the orchestration. So how is this all connecting together? The piece that's behind the chat, which is the router, or as I like to call it, the brain of the whole system. So this is often implemented by agents, which you've probably all heard of by now, but I'll quickly cover what they can do. So like normal prompting techniques, they may have memory, but what they have additionally is a lot more freedom. They can do planning, they can think ahead. They have this freedom to make actions. So act on the environment. How they do this is through the use of tools. These may be Python functions, APIs, connection to databases, etc. But they have this impact which makes them a lot more powerful. So let me make a quick analogy. An agent is somewhat like a chef. So when you go to a restaurant and you sit down, you open the menu, and you want to ask for a certain thing, okay? So you want to ask for that lovely pasta I was talking about. You ask for it and you just state what you want and your expectations. You don't state the whole recipe, step by step, what it should do. So an agent has the ability to look at what you want and understand, okay, so I need this thing, I need that ingredient, Oh, but you know what? Tomato is missing. I need to go get it from the fridge. Oh, I don't have it in the fridge. Maybe I'll improvise with another ingredient. So it has all these degrees of freedom, which make it awesome. But I'm talking like, wow, it's so awesome, right? Have we reached AGI? Well, it depends. What do you think, Kat? Are agents this incredible?
So what I'm trying to understand, when you're talking about agents, how does that relate to prompt engineering? Because agents sound to me like an LLM that is capable. Like, how do you use prompt engineering in order to achieve this kind of behavior of decision making?
Yeah, great question. And just to touch on something, I love your comment, Charles. Yeah, I don't believe personally it's not AGI also. And let's see how it actually is implemented. So these agents are no more than types of design patterns of prompts. Okay, so maybe you know a lot of these: tree of thought, react, rewoo, reflection. If you want to know more about these and more design patterns, we have a great blog post that you can check out later. But for now, I don't want for us to focus on just one of these. So let's look at React, one of the more famous ones. It's all about reasoning before acting on an environment, observing the change, and then doing this process all over again. How would you normally use it in a library like LangChain? You wouldn't think much of it. You would just do, okay, let me pull up the design pattern of React, the prompt, and you get a prompt, and now you use it and you don't think about it even. But here we wanted to show you how it actually works behind the scenes. So what is this prompt that it uses? So we went, we pulled it, and we printed it. And what it says is, oh, try to answer these questions the best you can. You have access to a set of tools. So these tools are user-defined, can be access database, etc. But you have to use the following format: question, thought, action, observation. And the action may be using tools. And then it loops over these steps over and over again until it feels like it has the final answer.
I see, and it kind of relates to a question that is already in the Q&A about, is it possible to instruct the LLM to handle a specific upload of a file? So in that regard, if I understand correctly what you're saying here, I have here the notion of tools names, in which I give it here the tools. And one of the tools could be upload a file or handle a specific file. That could go and call a Python function that loads the file, deletes the file. So yeah, I'm not sure what the question was regarding how to deal with the uploaded file. But once I kind of know the logic of how I want to deal with the file, I can use the React framework in order to identify that the file was uploaded and then make a decision based on the kind of logic that I define through the prompt engineering of the tool itself, right?
Yes, of course. And with that said, I do want to make it even more clear and show an example of how it is done. So let's look at an actual example. Okay, so imagine that we have a travel chatbot or assistant, and we make a query saying, oh, I want to reschedule my flight from Madrid to Paris from the 10th to the 12th. Okay, and immediately it activates this React framework where it first does a thought, and I need to search for flights. It does an action, so it uses a tool, like you said, Gad, to maybe search a database, go and search the web, something, observes it, and then keeps looping. Thought, action, observation, thought, action, observation, until it understands that it has reached the final answer. Now, this seems amazing, right?
Sorry to interrupt you. Is this loop being implemented inside the LLM as a process of, is the LLM performing the loop, or is it a loop that is implemented in a Python maybe code that is external, and the LLM just keeps calling itself, telling the Python, oh, I actually need to run again because I haven't reached to the final decision?
So it might differ on implementations, but I say that usually it evaluates itself on, so it uses a prompt to evaluate, should I restart this process? And if it should, it might call a new Python function. But most times I'd say it's just in one prompt. It tries to do this over and over again until it gets there.
Okay, I see.
But with that said, I mean, this seems amazing. But you were talking about loops, Gad, and that's a very important thing, because how does it know to get to the end of the loop? What's the final criteria? And this is where these agents often fail, and we have seen several cases. So for example, here, a person is complaining that the agent never completes a task. It goes on and on and on in these loops. It goes for hours, it costs a lot, and it gets nowhere. And by the end, when it finally gets an answer, it has completely deviated in a different path than the original task, because it has gone in so many rabbit holes that it's so far from the beginning. This is one of their limitations, or something you have to be careful with, some risks it has. So then comes a question of, so what is in fact a good agent? And I wanted to ask you, Stephanie, can you help me with this? What is a good agent?
Well, we were talking much like the chef scenario, right? Or just right now when you were talking about it looping for too long and coming back with a mismatch on the answer. So when you were talking about ordering a meal, you want your meal to come back on time at the right temperature. We want our agents to act like that as well. We want them to bring back our information on time. And while most tasks can take a little longer, many of them really can't. So, and it's especially important when you think about the underlying cost per token of the information. So, Gad, what is the future of prompt engineering?
Yeah. So I think talking about the future, especially in LLM, is a bit difficult because who knew ChatGPT would come out? But I think a lot of people are talking about whether prompt engineering is here to stay. And I'm seeing here somebody's asking about prompt breeder of DeepMind. which is kind of the question of, if LLMs are so smart, can they just write their own prompt engineering? Do we actually need people? Do we need to pay $300K a year for a person to write prompts? Or can we just ask the LLMs to write their own prompts? So I think personally, I don't see LLMs taking over completely in the near future. And again, I want to give a huge disclaimer about this. We all don't know what will come up next month out of OpenAI, but I do want to give a framework in which you can leverage LLMs to kind of improve or understand your prompt engineering. So think about the days where GPT-3 just came out, and OpenAI opened it for the whole world. It became one of the most popular applications to reach a million users. Or I think the first application to meet a million users in less than a week. Quite remarkable, but still people didn't know what they can do with it. So this work is actually presenting the concept of self-instruct LLMs, in which you're creating some kind of 175 seed tasks, and then you're using LLMs in order to go ahead and create some prompts and actions that are going to be expanding on these tasks and creating some more prompts to fulfill these tasks. And then you're creating a task pool. You're asking an LLM to perform these tasks. You're checking the validity of it, and you're going back to updating your task pool. And gradually you are creating this database of well-crafted prompts that are coming out of the LLM. Now, apparently, many of these are actually rubbish. So when Gail was talking here about Auto GPT that seem to have failed, if you are confident, if you want to be confident that the instructions that you're going to get out of the LLM are going to be correct, especially in the context of your business users or your business use case or your intent, probably it's going to be wrong. But for the sake of understanding your limitations or the boundaries of your LLM application, this is where these kind of systems actually do shine. What they did after running this in a loop is that they created statistics, and they could understand some, for example, structures about the prompt engineering, about the prompts that were engineered by the LLMs in order to perform these 175 tasks. So they could see that a very common word that the LLMs use that actually survives through some phases of validation was right. And then right was then associated with noun like a function or an essay or a letter. So it kind of gives you in this case, it kind of gives you the variety of options of your LLM application, of your prompts in order to get what you want of your LLM application. So I think my point here would be, I still don't see LLMs self-instructing themselves. And somebody wrote here about prompt reader. I would like to see one day like a self-instructing LLM that is fully capable. I'm not sure how far we are from that. Somebody mentioned AGI. I think we're still far away from AGI, but I do think there are some mass techniques that you can use prompt engineering using LLMs in order to collect some more boundaries about the possibility of your LLM application to perform. We are a bit over time. I did wanted to summarize and talk about what we've seen today. So I think we've went through a bit of history and talked about where did LLMs came from and how do they compare against traditional machine learning and deep learning, in which actually the fact that they're very capable creates a new problem in which how do we actually make them do what we want. We've seen the very, very basic techniques like chain of thought and few shot. And I really recommend that if you don't know them, you can go and read. It will take you a few minutes to understand them. So it's great to go back to this video later and try to understand, try to figure out which ones you don't know and go read about it. I think what we try to give you is the concept of think well about how you design your prompts, think well about the context of your application, talk to your product people, consider your privacy concerns, and most importantly, don't take API calls as granted. Try to understand what's running in the underlying and leverage LLMs and prompt engineering to kind of like tune your LLM application to where your business needs. It kind of brings me to the last point just before you're going to say goodbye to everyone, which is why would an LLM project succeed or fail? And I think that in many of the cases, and Stephanie can probably mention a few cases that you've seen before, is that you're meeting this incredible technology, right? In the 90s, it might have been databases, and then like the internet, and so on. So Stephanie, you have like other examples that you've seen?
Oh,
I could
perfect.
go on and on. You know, with the history of as many products and services that we've all put together, I bet each one of us has our own unique experience. In the efficiency of time, as we're 7 minutes over, I'd love for you to go through this really cool image we've got here. We never get out of the garage.
Yeah, so I think eventually you can stay with your amazing LLM in the garage and never get to production because you haven't put on the right wheels. And very often the right wheels in the context of LLMs is the prompts. So my one intuition to you is make sure that you're putting in the right wheels to your LLM applications. Some of them are some wheels that you don't even realize that you had to combine because you just use LangChain. You don't realize there's like a prompt being called in the underlying layer. So if you really want to get your machine out of the garage, prompt engineering is a very important topic to pay attention to. And
we really
yeah.
appreciate everybody coming today. Gad, you've done a great job. Gad and Miguel, I really loved how the both of you interacted together to make this much more valuable for all of the folks that have joined us. We hope you've all enjoyed today's presentation, and there's going to be more information to come, possibly future presentations with us both, definitely future presentations with Tensor Ops. One of the things that we might want to take a deep dive in is about business process in relationship to implementing your LLMs. The other option is for you to tell us all what you're looking for. Will you be doing a survey after this, Gad?
Yeah, we're going to send people some answers to questions that we may have not answered. If you want to leave us a comment right now, if you're going to get in touch, we'll send you an email if you're registered through this webinar. Hopefully send you all the materials quite soon.
Thank you for joining us.
Yeah, thank you so much, everyone. Glad to be here.